Lesson number 87 is called More on Systems of Equations and Tests for Functions. We're going to start with systems of equations, and this problem says, given the subscripted variables, find TE, T sub E, and T sub W. So we're given these equations, R sub E, T sub E equals R sub W, T sub W. R sub W equals 250, T sub E plus T sub W equals 9, and R sub E equals 200. Now we're going to solve this problem the same way we've solved them in the past. Let's substitute the values that we know in. We know R sub W is 250, so let's substitute that in for R sub W. We'll multiply that times T sub W, and it's all going to equal, well, we know R sub E is 200, so we're going to get 200, and then we have T sub E. Now this problem is slightly different because we now have two unknowns in one equation. So somehow we need to replace one of these two unknowns with something that we do know. And let's go ahead and let's solve this one for T sub E. So in this problem, we need to say T sub E is going to be equal to, we'll subtract T sub W from both sides. So it's going to be equal to 9 minus T sub W. Now let's substitute that in for T sub E. So T sub E, that's going to be 9 minus T sub W. And then we can go ahead and solve. We're going to have 200 times 9 minus T sub W equals 250 times T sub W. We're going to use our distributive property, so 200 times 9 is 1800 minus 200 T sub W equals 250 T sub W. Now we'll add 200 T sub W to both sides. And we're going to get 1800 equals, when we add this to both sides, we're going to get 250 plus 200, that's 450 T sub W. And now we can go ahead and find our final answer. We're going to find our final answer by dividing 1800 by 450. Now if you double 450, you get 900, and if you double 900, you get 1800. So this whole thing is going to equal T sub W, which must be equal to 4. 4 equals T sub W. Now we've got about 99% of our work done, but only half of our answers. We've got T sub W, that's here, but we still need T sub E. So here we go. T sub E plus T sub W equals 9. Well, if T sub W is 4, then T sub E, that must be 5, because 5 plus 4 equals 9. So T sub E, that's going to equal 5. And now we've got our final answer. We could have done this problem another way. We could have done it to solve for T sub W by subtracting T sub E on both sides. We would have had slightly different work as we went, but we would have come to exactly the same answer. It doesn't matter which one you pick, T sub E or T sub W. Work through the problem carefully, take your time, show your work as you go, and you'll get the correct final answers in the end. Let's look at some tests for functions. Now, these two questions say, determine if the graphs represent a function. And then down here, you can tell this is important. A function, every input only has one output. So that means everywhere we see an x value, we're only going to have one y value. So if we look at this graph on the left, everywhere there's an x value, we only get one corresponding y value. Okay? So this is a function, yes, because every input only has one output. Now this one, for every x value that we have, so if we had x is negative 2, well, we've got one output and two outputs. Over here, if x were equal to 1, 2, 3, we have one output. Oh, we have another output for the same input. There's no way that this can be a function. Now there's a nice test that we can use in order to figure this out. We're going to come back to this page in a moment, but let's move forward. The vertical line test. The vertical line test tells us that a graph is a function if a vertical line drawn only intersects the graph one time. please pause the video to get that written down. Okay, let's go backwards for a moment. If we use that vertical line test, we'll take a vertical line, and if the vertical line only hits the graph one time, we have a function. So right here, that vertical line only hits the graph once. It only hits the graph once there, only hits the graph once here, and we could keep doing this vertical line test everywhere, and we can see that the vertical line would only touch the graph once. So this is a function. On the other hand, a vertical line drawn on our graph on the right, this hits once twice. We do it again, this hits once twice. If that happens, it only has to happen once in a graph to make it not a function. So the graph on the right failed the vertical line test, so it's not a function. The graph on the left passed the vertical line test, so it is a function. Lesson practice will be on page 364. Make sure you've got your notes complete, and I'll see you during our next class.